So can someone tell me if is that a solution? And where would I put it? What do I do?
No.
No? Okay, where do I put it? By the 6. And what's happening in this picture? Multiplying. So anytime a number sits right beside a variable, it's assumed to be multiplication. It is a rule, it's multiplication. So then I put it in this like multiplying format so that I, as a reader, know that I'm going to multiply that, and then it becomes order of operations, but I have to do that first and then subtract the 4. So what did you get there? These are the multiplication numbers I still have trouble with. I get this mixed up with 8 times 7. Anybody else? No. My husband kind of looked at me like I was dumb, like the other night when I was kind of trying to relate to my little dude, and I was like, the 9s and 6 and the 8 and 7. That little picture always gets me. What is it? Negative 54. Why is it negative?
I mean, the nonsense.
Non-negative. One negative stays negative when you're multiplying. And we wrote that on the board last time. One negative stay, and I wrote it way down here, but one negative stays negative when multiplying, 2 negatives make it positive when multiplying, but 2 negatives stay negative when you're adding negative numbers. Those are the pieces that people two negatives. It has to be an even number. Oh, we didn't talk about that. So I went back over the sign rules. I'll do that. And so then multiply, divide, 1 negative stays negative. Forgot. It's going to be a blur, especially since I teach the one class over and over again. And then so sign rules, I'm gonna write those up. This is not, you've got a calculator, but it just takes out the distraction of having to go put it in your calculator and then go back to the problem. Having to multiple steps, the more you can take out of the work, because your focus is solving equations. All the arithmetic, the negatives times positive and the yada yada is all needs to be more automatic. Again, we're very thankful to have calculators help us because our focus is more about solving the equations. But I do like to pop these up here because signs were my main issue. And once I got those, the rest of my math worked. Like I finally understood everything. So my sign rules are same signs. So I don't look at what the operation is telling me to do. Like this right here looks like it's saying to subtract, right? And you are. Like if you think about having negative $54 in your account and taking away 4 more, you are subtracting. But the stuff that you do in your head is you're adding to your debt. Like you're adding those two. So same signs, we add the numbers. So I just stopped thinking about the visual of it. That helped me for a little while, but then it didn't help me with multiplying because I still can't tell you why 2 negatives become a positive. I've looked it up and I must not have understood it because I didn't hold on to it. So we add the numbers. So this is just rules that help me understand when I'm doing that kind of math, this is what I do. Add the numbers and keep their common sign. And then opposite signs, negative and positive. I subtract. So let's say that let's write it that way. It's not, this does not say the same thing. But again, this is just a way of thinking about it because this helped me wrap my head around it and stop overthinking it. Subtract the smallest. So that's just the smallest number, not looking at their signs. Because obviously 54 is smaller than 4, but I'm not looking at that sign. I'm going to do this step on, and I'm going to do both steps on just the numbers. And then once I go back to make a decision about the sign, I go back and then I'm like, who has the negative? The smallest from the biggest. Keep sign of biggest. And so these are just little tips that I added down here that I feel like it's important for us because we're going to be doing both of these operations in the same equation as we go along. And as we keep evolving our math, we're going to have to be able to go back and forth. And it's really important that we understand that adding two negative numbers is going to stay negative, but multiplying two negatives is going to equal positive. I promise once I start seeing your work, your scratch work, y'all wind up getting those back mixed up because you just are going so fast. Or in your, it's a lot of information. So again, in this format, I'm going to subtract those two and get 50, right? Because I'm not thinking about the signs. But then I'm going to look and see which one's the biggest. So that's going to hold the sign. So there's where my work happened. I have a lot, I mean, yes, the visual definitely helped me with adding and subtracting. And that's, you're welcome to do that. I just get confused when there's extra. So like this picture. So this says the same as this. And so this also says the same. Like I could say that the same way. I put a plus sign, and that, I think the rule used to be when you're subtracting negative numbers, you add the opposite. And I could not wrap my head around that as a student. I just could not. And so that may work for y'all. And you may be like, whoa, what's wrong with her? But this was too messy. It almost felt like I had more going on than I actually do. So for me, if I ever see this picture, I'm probably going to write it without that plus sign because it's easier for me to see that I'm adding, but whatever works for you. So we don't necessarily talk about these as being subtractions as much as I'm more interested in the fact that it's negative. That all makes sense so far. I'm sure this is all like great. I didn't need that, but whatever. So when we get down here, and we do this adding and keep going in the whole, we get that 58 does not equal, sorry, negative 58 does not equal negative 57. How are we with that? So then it would be no. So that's just kind of an introduction of like the idea of what you're doing here, that this is what we're going to be going for. Our goal is going to be looking for some variable equals some number as we move things around and move things off of the variable. That's what you're trying to do. So I'm going to be trying to get this guy by itself. And I'm not going to maybe put all this on it. So you've got to decide what all is attached to it and where things need to go. And that's where, so we start real slow in the beginning of this chapter in the semester with all these simpler, they may not be simple to you, but there's some of you that it might be really simple and feel really unnecessary. But this was as if this was back in the pandemic when I was like, you guys aren't coming to class and you're not watching the video. So it's like, I need you to be able to like learn the steps so that you understand one-step equations, and then we build into the others one-step equation, and then we'll see from there. But so this one is rather obvious, right? I mean, we can use logic and guess what that might be. Still here. Yeah. Okay. So we're going to start introducing our steps though, and add or subtract step. So our goal here, I'm going to build into some layers to this that may not be necessary to you, but as you get into the bigger, more complicated ones, it might make more sense and be more valuable. I'm gonna label all my pieces. So this is my variable, this is my number, and this is a number. And then that's my wall. That's really important to understand that it has significance, that it is important that we make it clear that that's what we're working with, and that's how we make our decisions about our rules, is going over the wall. So I want to get this term to be by itself. It's got a number attached to it. So the step here is to get rid of what's attached to it. And then but in the beginning, you have to decide what's being done to it. It has a positive 10 attached to it through addition, right? Like, so this is happening. What gets rid of a positive? A negative. So a negative of the same amount of that same number will create a 0. And you do not have to show me this step. When we get into what you have to show me, you'll understand more. So I created a 0 here. But whatever I do to one side, it's like that scale. If I take beans off one side, I've got to take them off the other in order to keep the scale balance. Same thing. Oops. When and this becomes just an operation. So you do the subtraction, and we did that in our head there. We got 31. This is where we're not going to write this 0 anymore. We just need to understand now that we're creating 0. When we add or subtract, we use opposite signs. And the goal is to create a 0. So when you add and subtract and you're going over the wall, you're creating 0 where you're attached to the variable. So this should just be, we'll eventually get to where we don't write this there. So you get multiple questions on this level. I think there's like 4 or 5. A little bit of volume. So the next one is not so obvious, right? We've got negative 30 equals x minus 19. So the question is, and the variable's not on the left side. I mean, you're welcome to just flip that guy, but you have to make sure everything gets flipped with it, like the signs and everything. If you want to keep your variable on the left, but you can also work towards getting just your variable isolated. It doesn't matter what side it falls on. It's going to matter when we get into inequalities, solving inequalities. But in these, it doesn't matter. So I'm going to work with what we've got. This has a variable there and a number here and a number. So I'm going to create 0 to make it go away by using the opposite sign. Whatever I do to one side, I must do the other. So those are gone. I could write myself a 0 to show myself that. Doing the math here was just subtraction. Subtraction because it's opposite signs for me. For me, may not be something you need to work with there. Questions so far? Feels very simple. Those of you who are, this is feeling very clean and easy, relax in that. This is the same thing. Is it cool if I go ahead and skip over it? I'm just kidding. It is the same rule, but when I first built this course, I said, okay, the next ones are all the same, and I just didn't pay attention to the one that was a fraction, and every time everyone come in, I don't understand that fraction one. I'm like, I get it, I do, because mainly you're like fractions, and you like shut down. Thank you. Oh, I heard some talking, and so this is good for us to go ahead and get comfortable with the fact that I do not do well. Yeah, it is because I borrowed. With all this, like I'll get signs, so just, I love it because that means you're paying attention. I used to be like, oh no, but I think it's great. Which one are we gonna use this time? I think it needs more control. Okay. It is exactly the same. It's a number. Fractions are numbers, a variable, and a number. So the process is still going to be the same. And in fact, you could almost give yourself the fact that whatever's attached to the variable, you can go ahead and put that sign up there so that you know that you're going to need to use the opposite sign of that. But either way, however you want to look at it, it's just like this one, but it's just ugly. And so then we get into the challenge of this class is about solving equations. This class is assuming that you know fractions. And not everybody does, right? Like everybody kind of panics. So I don't mind like having a little side lecture on like a side lesson, quick, like how to do this by hand. But I don't want you spending energy mentally because you'll get lost in all the steps there and forget how to do that. What I need to see is that you know how to solve equations. I can teach you how to do this stuff in a calculator. So our goal is more about what you can do with the numbers and with the algebra than it is about the math. Because the math, you're again assumed to be able to do it. So that being said, let me write in some notes for the calculator. So calculator. Option 1. We just type it in as we find it, as we see it. What you have to remind yourself is that fractions are actually division numbers, division questions. Like, so if I wrote the fraction 12/3, actually, let's go back and do one a little simpler. Let's do 6/3. That's a fraction. It's just not simplified, but it is a fraction. But it's also, notice what, if I simplify that, what does it become? 2. So then it's really division. So fractions and divisions and decimals are all the same. They're just different ways of looking at each type of number. So 6/3 can be written as 2. It can be written as 2/1, right? That's how we write a whole number as a fraction. And this comes in when I'm looking at recipes, when I'm cooking. If I've already dirtied up the whole cup, measuring cup, I'm gonna be looking around for something else, and then I have to do the math on how many I'm gonna need of that. So if the recipe called for two full cups, I need to be knowing that I need 6 1/3 cups if I have, that's what I'm going to use. And I am notorious for doing that really because I don't like messing up my, I don't like washing dishes. So I just try to use the same one the whole time. So whatever I start with is what I wind up using, and it kind of gets messy when I get into those needing a bigger amount. That being said, this is division. So in my calculator, I would type in -1 divided by 3 inside of parentheses for me. You don't always have to write that. Like, in fact, I'm not going to. That's it. Okay, so let's go here. That I'm going to use this as a 1/3 and showing how the calculator goes. I'm not going to do anything for this question though. Let's do plus 2/5. Because we're not doing that correctly even if we did do it. So -1/3 plus 2/5. This is just an example for how to use your calculator. You can type it in just like that. Now, I have students from my last class that were like, do I need the parentheses? And maybe not. I just don't take any chances because I was in the day when we didn't have the fraction button and we just didn't know anything. And so we always put anything that was a fraction, we put in parentheses. So remember also that you need to use a negative. The minus sign and the negative sign are different. So be careful with that. 1 divided by 3 plus. And so again, I want the computer to know that I'm talking about a fraction. So 2 divided by 5. And then you're just going to press enter. You get a decimal. So you're going to go math. Number 1. And then enter twice. So going back out here, I go to math. Right there at the top, number 1 is the fraction button saying that you're going to switch it back to a fraction. You're going to switch whatever you're asking, whatever you just did to switch it back to a fraction. And it's going to take the answer and give it back to us in 1/15. So that's if you just like bare bones, don't want to try to understand the calculator, because the calculator gets messy on the options that you have. You do have an option 2. And that's using the calculator and its fraction buttons. So if you want alpha, if we want to see it in this form, let me see if I can get up there. Oh, in that top and bottom form, we would use these buttons I'm about to show you. So I think a lot of my students like that. I personally don't need it, but y'all like to see it because you can then see where the negative sits and see that you typed it in exactly like the computer. So a lot of my students really like this. It's more keystrokes to me. And so I go under alpha and then y equals. And then enter. And so enter is using this number 1. I would scroll down if I want something else. You really don't need anything else. So then that's, again, I typed on my keyboard yesterday and wrote and used a negative. This minus sign is not a negative for the computer's sake. It wants you to use the one that's down by the 0 and the dot. So 1/3, and make sure to cursor. And then you're going to cursor out from under those fraction boxes so that you can keep typing. Otherwise, it'll type underneath there. And then plus, I have to go back and ask for another alpha, y equals fraction box. And so there it looks like it does on the board if I written it that way. So those are your 2 options using the calculator. If we're going to do it by hand, which is what I'm going to do, because I'm going to do most of mine by hand because I don't want to slow down and stop and use the calculator, right? This is me making me go back and forth. I like to stay at the board. So yes. Yeah. So that's a come and go as long as it doesn't become like a high traffic thing. Okay, so going back to the simplicity of this being a variable and 2 numbers, we need this number to go sit with that number. What do I need to make that piece move? Thoughts? Anybody have an idea on what I need to do? What can you decide is going on? So what's going on? Let's look at it as if that were a -3 plus x. What needs to happen here? We need to add whatever's being attached to the variable because it's negative. Whatever's being attached needs to be a positive to help us cancel it out. A positive 1/3 and a negative 1/3 create a zero, just like a -3 and a +3 create a zero. So that's our goal. And whatever you do to one side, we've got to do the other. So we're not really even dealing with fractions yet. That should be plus, sorry. We're not even dealing with fractions yet. We're just moving. We're just using that. This is the algebra part. All we did right here was algebra. So move that 1/3 over. And this is where we get, everybody gets like, I don't want to do this. This is where you put it in your calculator and be done. Just use one of these options and be done. So does anybody have any thoughts about what I might need to do? Anybody brave enough to wing it with me? That's real messy. What do I need? So right now, this is a different measuring cup than this. My pizza is cut in different slices. In order for me to add and subtract, in order for me to add or subtract with measurements, they have to be the same measurement, or I have to know their equivalents. So either I make this the equivalent, which is what we're going to do, or use a calculator. So making this be equivalent means I need an LCD. LCD is your size of your pizza. So when you're cutting up your pizza, it's 8 slices. Obviously, they're not the right size. I mean, they're not all the same size, but if you have 1/4 sizes, you're going to have to cut those in order to make them where you can add and subtract them. So let's make these both be 24. So that needs an LCD. And we can find the LCD in our calculator. Your LCD option is the math. You're going to scoot over to number and scroll down to the LCM. That's the same thing as the LCD. LCM for 24, and I use a comma because I'm listing 2 numbers that I want it to find the LCD for. So that's just a list. Anytime we're doing a list, you use a comma. And it gave us that it's 24. So 24 is our LCD. That's what I need both of these to be. This one is already 24, so I don't need to do anything with it, but I do like to just go ahead and scoot it over because I'm about to do stuff to this one and just be done with that one. So I'm just rewriting it so that I keep clean on where my stuff is. In order to change 3 to 24, what do I need to do? Oh, yeah. So when you divide, what do you get? 8. Yeah. And so what am I doing with that 8? What did I do to that 8? With that 8 to the 3? Multiply. Yeah. So then we now have 8. On top, it's a new fraction. So now we're talking about the same amount. Now we're able to compare apples to apples here. So we've got -1, then we get it. So let me get it. So this is taking you all the way back to the way I used to teach fractions. Then I pull, once that denominator is the same on both of those, it is now the denominator. I'm not going to add those. It now stays untouched. And I bring all the numerators to the top. And then I do the arithmetic on that. And so that becomes, I feel like I did something wrong. Did we write it right? Well, it's supposed to need to reduce or something. I may have written it wrong. Where?
You took a -1 and a +1. Right there,
Which is -1 + 8.
But it's negative up here. Oh, it's 7. We wrote it down wrong. So yeah, it's negative up here, it's negative up here, so it needs to be negative right there. But we have a typo. That's what it was. So 7, -7, -7. And that's when we subtract it. We get a 1/24. So I want to go real quick back to this question could give you one that is going to need to be simplified. This one would need to be simplified. So this is it. That's doing it by hand. This is what I would do in my brain when I'm doing it. So I'm trying to get over here to show some simplifying. So when I need to do the exact same thing that I just did here, it's actually going to be the same LCD and the same multiplication. It's just that this number is going to be different. And I get 3/24. That's what I was trying to get to. So beyond all this extra work that you're doing by hand that's taking you away from the solving skill, you also have to make sure your answer is in the most reduced form. Because we have to do that by hand. If you're not using a calculator, you have to do it by, you have to see it. Luckily, it doesn't matter which option you choose, it's going to give you the most reduced answer. So I'm right here, and if I'm not paying attention, I might think I'm done. But what do I do so we're really doing this fraction talk. What do I need in order to see it, or like what I need to simplify? Simplify means to make smaller for fractions. How do I do that? So it's tempting. So that's where these two start getting mixed up. That's the LCD, that makes things bigger. And so then it's going to be the other one, the GCX. I need a GCX. I need the biggest factor that can come out of both of them. Greatest common factor. So I divide that out. You get 1/8. So the second example, it might be helpful to take a picture. I highly encourage taking pictures as well as we go along. And you just tell me to stop. If I'm about to erase something and you wanted to take a picture, tell me to stop, because I'm telling you, the way I write things down and the way you're taking notes might not be the same. Or once you go try it and revisit it again, you might want to have the way I did it as an option. It is an option. You may not want it. You may not use it, and that's okay. Oh, sorry, if you're trying to get into my little tips over here too, I'll leave those on the board for most of the class, just because it's good to reflect back on. Okay. So that's our side note on adding and subtracting fractions. We'll obviously come across multiplying and dividing soon. So now we're into the second rule that we have. So these are two individual rules, depending on what you have. Making the decision on what you're supposed to use comes with understanding what's happening between the two variables. Sorry, the two terms, the variable and the coefficient is what we'll call that, the number in front of the variable. So I don't have two terms. That's the main thing you want to pay attention to is these two pieces are different. This has a plus sign in between it. This does not, and you have to know what is going on in between it. Inevitably, when y'all get going on these, you tend to get those mixed up, so be careful. This has three terms. That's also something that helps me. It's like, oh, this has one. People still try to give this a number, but it's not. This is a variable term. That variable has a number. That number belongs to that variable. And so we're already in this format of a variable equals a number. So then you're like, oh, I must be done. And that's where we get into what do we need to do to solve that? We need this to be 1 in front. So what would cause that 3 to turn into a 1? Divide what? 3. You create that 1. And that's just happening with the numbers. I have a lot of students that do this and mark it out, but they don't take their variable with it. And you'll see that more when you get into more complicated questions. Right here, it's pretty obvious it shouldn't happen, but y'all do wind up wanting to get rid of that whole X, like you put the X on the bottom too. We are not getting rid of the X. The X's, we're trying to hold that where it is. We create that one, whatever you do to one side, you do the other. And we get that our answer, our solution to this one is 8. So our next rule will be multiply, divide. Use same sign. Because did I use the opposite signs? That's another thing. We start getting super mixed up on these rules. But the more you practice them, the more familiar and comfortable you'll get with them. And we create 1. So what the work we're doing attached to the variable is same signs and creating a 1. So that's the difference between these two processes. This rule is creating 0, this rule is creating 1. So you get more practice with those. Build that confidence. Let's just real quick go over an example like that. This is where we get confused because, or like we think opposite signs, because that's the rule we just gone over and we really hammered that one. And it just feels like that's what we should do to get rid of it. And it would if we were adding or subtracting. But again, in this picture, it's attached to the variable, not with an addition or subtraction sign. So I have to undo it with what it's attached with. So the opposite of multiplication is division. Well, in order for us to see this a little bit more clearly that we need a same sign, let's think of it as creating a 1. So in order to create a positive 1, so that's what you're going for, is this variable with a positive 1 in front of it. Create that 1, and we just don't write that 1. So if you don't see a number in front of the variable, it's assumed to be 1. And so whatever you do one side, you do the other. So that's where we're getting into that same sign. You need to use the same sign with multiply and divide, opposite signs for add and subtract. And that goes back into that 2 negatives equal a positive. And that's what we're trying to create up there. I threw this one in there. I really like it because we get into this particular example at the bottom of your solving in a lot of our equations. And it's really just starting to talk about how a negative just flips the sign. So we're going to use the tool of multiplying or dividing by a negative in order to flip the sign all across this semester. And so that's all that's happening right here, is that yes, it's already set up. I've already got down to a 1, but it's not positive. So how am I going to make that positive? What do I need? And what do I need to make that go away? Make that be positive. To create a positive 1. So what's in front of it right now? Negative 1. And so I want to create a positive 1. What do I need? So if I'm doing multiplication and division, what am I doing?
Negative.
So this says multiply and divide 2 negatives. So if I'm dividing, in order to create a positive over here, I need another negative. So there's an assumed 1 sitting right there. We created that, but really what I want you to get more comfortable and natural with is that negative, anytime you get down to a position like that, it's just a simple flip the sign of your answer. That's all, and we use it a lot because we need it. Like that tool, we're going to need to switch the signs to make math some of our algebra work. And so that's just good to go ahead and start having it in our pocket. Seems silly, seemed really easy, but you'll see as we keep revisiting using the negative for our advantage. So then we get into these, where we're going to get into the multiply and divide of fractions. Questions so far? Does it feel really simple? I hope so. But I mean, that's my goal. I mean, my goal is that you've already done it and you really only have questions for like the last 6. Is that about right?
Yeah.
Good. So definitely be paying attention though. I may teach it, I may explain something a little different and you're like, oh, I see that a little differently. It may be a simpler way to do it. Or not. So then we look at what's going on here. Wait a second. Okay. We're gonna leave off. There we go. This is, you can use your calculator and just boil your way through it. And remember that this is a number, a coefficient is just a fractional coefficient. The number in front of the variable is a fraction, does not change what you do with it. So if I have a 2 in front of X, I'm still undoing that process with division. So what am I doing right here?
Dividing by 2/7.
And so this is probably, I don't know, this is kind of filling in the gap from where the book may have left off. They kind of assume you know a lot of this stuff. So there's maybe some stuff that they skip over. And they say to multiply by the reciprocal. We'll talk about that. So, but right now we're just going to say, I'm just going to divide both sides by 2/7 and be done. And use your calculator and do that. That's fine for these. I do need you to understand the multiply by the reciprocal. So in order to create, this does create our 1, right? Because it's the same thing over the same thing. Let's look at that though as division. What do we remember about the rules for multiplication and division of fractions? Or just say multiplication. What do we do for multiplying fractions? Oh, good question. So this is where people would want to move over and be like, is there a common denominator? No, we don't necessarily need a common denominator. We're just going to multiply cross top, multiply cross bottom. And so you get 14 over 24. And then the rule for fraction, for division, is that you actually don't ever divide in fractions because you always change your division sign to a multiplication and flip the second, which is the rule. We don't divide in fractions, we multiply by the reciprocal. This is the reciprocal. And so we wind up not needing this, even though it is part of the, it was your question, but then we've got 16 over 21. So those are 2 different problems. And if you wind up trying to simplify, you can't simplify early and we get all excited with fractions to cross simplify. I would have wanted to simplify those 2 because they can simplify, but not if it's not multiplication. Because multiplication creates this kind of bridge across the 2 terms to tell you that anything on top and anything on bottom in any position, if it's on top and bottom, it can cancel out. Like, so I'm just writing that 8 as a 2 times 4. So notice those are both one's in top and one's bottom. If they're in opposite positions from each other, yes, you can cross simplify, but that's only a multiplication. So back over here, let's apply that so we can see it. We do 2/7 divided by 2/7. That means 2/7 gets multiplied by the reciprocal, and there's your created 1. Even though we see it here, 2, we can also see it this way. And so this step right here is the shortcut. So instead of writing that as divided by 2/7, it's going to be, you've got to commit to this or commit to your shortcut. You can't do both. So I have a lot of students that then start getting this 2 method. You just got to practice. So then that 7, there's that picture of creating that 1. And whatever I do to one side, I have to do the other. So I'm multiplied by 7/2. And that's what would happen here is that is division, but eventually I would flip it over to 7/2 anyways, if I were doing it by hand. And so then if I'm multiplying a whole number times a fraction, how do I make, what do I do with that whole number? We what?
Negative fraction.
6/1, right? So I could write it like this. This is all by hand. If you're not seeing that the 2 and the 6 cancel, you would maybe see it here. That 2 will reduce with the 2 that's in the 6, making that 3. 21/1, because 1 times 1. So all of that. I'm gonna multiply, or sorry, erase this stuff and then leave that on the board for us to, you need a picture of it. So this is calculator, I guess you could say. And so the calculator will, if you put it in 6 divided by 2/7, it'll give you 21. So that's, and I need us to be comfortable with that conversation of multiplying reciprocal, because we're going to use it when we get into some more complicated stuff. Some more practice with that. And then in this example, this homework question, again, it's just because I want us to get comfortable hearing this terminology of like pulling that fraction, that these things can be written interchangeably. And there are a couple of things I wanted to say about writing things interchangeably. We talked about variables, whole number fractions. This is all the different ways you can write that. We cannot write 1/4. That is absolutely not going to work. That is not the same. Think about that as 4 whole pizzas and only eating 1/4 of a piece. Those are 2 different versions, 2 different amounts. So then I want to go back over to another conversation is where that negative sits. One negative stays negative. But that means that your negative can float to the top if you need it on top. Like if I'm going to do addition in the numerator, it can also be in the bottom, or if it was in the bottom, you can move it to the top. All of this is interchangeable. So again, this all says the same thing. That's what I'm trying to get to. And then, so this is true as well, that if I am going to work with that, 1/6 X, I want to write it in a different format, but say the same thing. The way we do that is remember that multiplication, if I'm multiplying by a whole number, that X is considered a whole number. So we would put a 1 under it. So it'd be 1/6 times X/1. And then as we multiply across top, multiply across the bottom, we get the X sits in the numerator. These 2 things are equivalent. I'm going to need you to understand that so that you know to pull that fraction off in front when we get to graphing. Or when we get to another question that you need to pull it off. You've got to understand that there's an assumed 1 sitting in front of that. And I need you to pull it off the front. But also need you to know that you can go backwards. Those 2, that's what you go backwards or forwards. This going this way, 4 to 12/3 is using an LCD. So this option, this question may have seemed silly, but it has purpose in the bigger and the overarching theme that we're doing. Because then we get into this question right here, where you're welcome to do it based on the way the book does, where it just says multiply, because you're undoing what's being done to the variable. We just don't use that as much as we use, well, yeah, we use all of it. So, but we really need to understand that that's a fraction that sits in front of that variable. Questions? You need to take a picture. Good. Okay, so lots of discussion on fractions because it's going to be assumed for the rest of the semester. So if you need help with fractions, we do, like that's what I was talking about with the tutor center. and, or just getting on Khan Academy, practicing, getting familiar with it, and then go ask questions, come to me and ask questions. I'm happy to answer questions too. So this is that concept of there's an assumed one right there that I want you to pull off. And again, if you found a way, if you're working this problem differently, you're welcome to keep doing that because I will follow. I can follow pretty much anyone's method. Like I've gotten really good at understanding your path. So make sure I understand what you're doing. You multiply by 4, tell me you're multiplying by 4. But I recommend that we multiply by the reciprocal as the shortcut here. And it needs to be a negative. We're inevitably going to forget the negative when we're multiplying by a reciprocal in front of a fraction. And that'll be just something you have to come over, just more practice and just awareness. So when I'm multiplying a whole number, and this was written in fraction form so that I could see that it cancels all out and makes me a nice, pretty positive 1. I don't necessarily have to keep it being a fraction if I'm now working with a whole number. So notice that this is a whole number, and I just put that over 1. Well, because it was the flip, but anything over 1 is the whole number. So I don't have to write that as a fraction if I'm working with a whole number. I only have to write that as a fraction when there's a number other than 1 in the numerator. How's this going for everybody? Anyone that is lost or confused or have a question? Feel really comfortable? Good. So now we're getting into the 2-step equations. So now we're getting into now we need to have order to what we're doing. So if you think about what's being done to the variable order of operations wise, that's how it's going to also be undone. So generally speaking, so parentheses and brackets, that's the P. This is the exponent. All right, that's really terrible. And then multiply and divide. And add or subtract. So this is the way we do arithmetic when we're doing a problem. This is how we undo. And so in order to undo this equation, I need to be working. This will generally be the case, except our parentheses do still come first. And you'll see that it'll be natural for you, but like the addition, main thing is realizing that you don't touch the number in front of the variable until the very end. It is your last step. So we undo, we're going this direction. So with that, we look at what we've got. Numbers on both sides and a variable on one side. So I don't have to do anything with moving the variable, but I do need to move that number. And again, that looks at like draw yourself a wall. And so when you've got something on the outside of the variable term, that's that whole addition subtraction step. So we're on this step. We'll always look through our equation. Is there anything that needs to add or subtract to go over the wall? And yes. So what am I going to do?
That's it.
Add 5. Sorry, my brain wrote 6 because I was already doing the math.
Yeah, well,
Sorry. So then we do what? What happens here? 6. And then these create a 0. And I'm going to highly recommend that you format your step to flow into a triangle, to come towards the wall, to stay aligned with the wall. Don't go towards the variable, stay towards the wall, because it'll help you stay with what goes over where. So then we scoot that variable term closer to the equal sign, and we solve by using our second step. So this was an add. Our first step was to add, which again, create 0. And our next step is to divide. Second and last step is to divide and create that 1. My quotation marks are very consistent. So then you get practice with these. 2-step equations are not terrible. for the most part. We're just adding in both steps. There's another fraction one that everybody gets uncomfortable with. Let's look at the overarching format, though, is that it's a variable number. And here's our wall. So the exact same process is still going to happen. Is there anything on the add and subtract step? Do I need to do anything on this level? And yes. And this is where you can use your fraction buttons and just do it that way. So we subtract that 1/3, subtract that 1/3. So then we scoop this guy in. And then we use that other, I mean, this is where you get into what you want to do. If you want to use your calculator and divide both sides by 7/3, I'm up here, so I'm going to do mine by hand, multiply by the reciprocal. And that was a negative times a negative, so it gave us a positive. And again, throw that in your calculator. How are we doing? This is the stuff everybody's like, oh, I don't want to learn that. And so then starting at number 19, and as we go further, we're going to add to the complication. So this introduces our new first step, what I call the cleanup step. That is your combined like terms. And we're going to do that by using the given signs. And it will always be to add or subtract. Don't go flipping the signs. So once we've introduced this rule, this add subtract rule, everybody tries to go ahead and use opposite signs for everything. And that is only if we're going over the wall. You only use these two rules for going over the wall. So 3x plus 10x. A lot of my students would already be thinking of subtracting one of the terms. But what we need to identify is actually, this is a cleanup step. I don't want to be going over the wall. I don't want to go over the wall until I'm down to one variable and one number. If it had more than one number, one variable and one number. So on both sides, I want to always come down to one variable, one number on both sides. Now, if I don't have that, like I don't have that here, I'm only going to be simplifying what I have. So I've got more than one variable. I want to work towards not having that. I need one. So you just use the signs that are given to them. And this seems very unnecessary. I understand that, but you'll see why I'm pushing it so hard. So then we divide by 13. Thank you. So moving on to the rest of those like that. More practice like that. I get worn out by fractions just as much as y'all do. They just wear me out. Because it takes a lot of extra brain space to work with those and work with these rules. And I have a neighbor that actually teaches math that had a really great analogy. How many of you lift weights? How many of you never lifted weights? How many of you lifted weights? And you were hoping, so what are you doing when you lift those weights? What's your goal? To make that muscle work, right? I want it to work. So I haven't been working out in like 2 years, okay? And it's now catching up to me. I worked out every day and I worked out hard and strong and all the time. And I'm now realizing, because back then it was because I was trying to stay into the size that was on my clothes, right? So I was trying to stay smaller. And then I realized I don't really have to do that. not like in a weird, just the way my brain works. And then, so I got lazy. But now I was trying to do something like pick up a kid. And I was like, whoa, not only are they just getting bigger, but like the work of using my muscles has become weak. So I need to lift some weights, right? I need to exercise that muscle. So the more we don't use our brain for stuff like this, the more we don't exercise our brain is a muscle. It's just like these muscles on our arms. So use that muscle, exercise that. This is what this says. So don't think of this as something that I have to go out and use. I'm not going to see Darius walking down the street with barbells, right? Or dumbbells, right? He'll never be hanging out with dumbbells. Just like you don't feel like you'll ever use this, but he's using and building that muscle so that he can do stuff with it later. That's what we're doing here. I liked it. I was like, yes, that makes a lot of sense to me, because it's hard to explain or justify why we have to do all this. It is simply just like those brain games that you have on your phone. Help to grow the brain. So you probably need to come over to the side and do a little side work of common denominator. This is up to you on this is what you want to do. So you would have to do this somewhere. Either you do this in the calculator and you get the 10-6, although it'll probably give you the most reduced form, and that's fine too. Whatever they give you, you can use. It's just a different version of it. You'll still get to the same answer. So the calculator would have given you 5/3, and we'll show that we can get to the same answer both ways. So, but either way, then we use our rule for getting that fraction off by multiplying by the reciprocal. And I slowed down and hesitated right there because I want to make sure I don't need a negative. I'm always checking on the divide part. I'm always asking, what do I need to do for my sign? Do I need a negative? Do I not? And so over here, we multiply by that reciprocal and we get 5. So with that, hey, I don't know. So we're not going to watch videos in here. I don't care if you don't pay attention to me, but we're not going to watch videos and listen to music. You can do that during your lab time if we have lab time. So right here, we've got, I'm going to go back and redo this one because your calculator will give you something more simplified. And just know that you can do the same thing, that it won't make anything happen, or it won't be any different. What did I do? Skylar, is that you? Girl, don't be listening to music. Thank you. So notice that we get the same answer, and I'm not saying that right. What happened here? Oh, there it is, 10. And it shouldn't be 10. Why am I doing this? Help me figure this out, guys. Oh, this is 6. The 3. It's not a 3, it's a 2. There it is. It is a 6. So that's where it was. Here's a 2. This will all happen in your calculator. You're going to put that in your calculator and it's going to give you the same answer. It's just that my brain was getting distracted by music, losing track of what I was trying to do. Okay. So it is not having anything to do with me when you listen to music. I mean, it has everything to do with me listening to music, but I don't take any offense to the fact that you may not be interested in what I'm saying. I just can't teach the rest of the people who are trying to pay attention when I hear music. Y'all saw me go over there and close Miss, I mean, I could barely hear, but it was enough for me to be like, wait a second. That's too much. I just can't do it all. So the more we stop me and ask questions and we talk about math, but let's not do anything outside of what we're trying to do here on the board until we are in lab time. So here we are in the ones where we're going to get into deciding which way to go. I'm going to generally go towards the left as much as possible with my variable. And I'm going to make this a rule for you. Please get over the fact that you don't like variables and move it first. I know you don't want to. I've learned that about y'all. It's like you go for the number because that you know what to do with the number, and that's what you've had the most practice with. But I need it, like it really does make the math. If you're successful with moving the number first, fine. But if you still struggle with solving, I want you to start adopting some of my methods. In a minute. So what we do here is the fact that we realize I've got variables on both sides and numbers on both sides. So I now need stuff to move around. I mean, yeah. So I need multiple terms to move across the wall. It's not just going to be a one-step move across the wall and be done. So this is where we get into multiple steps. Even if we're going to repeat the same step twice here and then do the multiply step. So we need to move. And which one would y'all like to move? It doesn't matter. It's just that once you make a decision, you then are committed to moving the other term. So which one do you want to move? You want to move the 2 to the 5? So I'm going to move that. And here's where the book is. I like to see them stacked under each other so that I can see it, so I can see what's happening here. The book probably still writes it all in one sentence. And so with that process, that is a plus. So that becomes 7y. Because I moved the y, the y to the left, I have to move the numbers to the right. Have to. In order to keep everything. Doesn't matter though that my students still want to do it this way. They'll wind up bringing the 29 over here. And then we get, because they've lost sight of their wall. When you're not writing down the wall and you're not going according to this format, you lose track. And I don't know what that is. What is that? 5:35. Thank you. 35. And so then they get this answer and they're like, but I just got the sign wrong. I about said mom. I just got the sign wrong. I just don't understand why I keep getting this wrong. It's because you're not working with, you're not doing my steps. I made these steps up. I don't need these steps. I made these steps up for y'all, for everyone else. So I'm going to move this over here. No, it looks like it, but that's a deeper in depth picture. It's that adding 2 negatives stay negative, and we're adding the same sign, so we're going to keep that common sign. So again, this is what we normally do. What a good handful of you do this. Y'all might surprise me this semester or not, but please do not at least pay attention to where they're going. So at this point, I have moved that over. I've now got 7y minus 6. It's really important to just keep writing down your steps and paying attention to where you are. So now I am required in order to get this question right to move the number term away from the variable term. We moved to the left, so we have to move the numbers to the right. And this is very easily a very frustrating part of what this math is for y'all. But the signs do matter. I certainly would rather have $5 in my account than -5.
So it's -6 minus -0.9.
Do it.
Do it. We flip it over and -6 minus -0.9. Right? 229, when you get the first, I know it's not right.
Oh.
So that'd be -6 minus 29, right?
Right.
That gives you 23.
-6 minus 29.
-6 minus 29.
Like you flip things to the other side, saying it is staying negative.
No, I'm saying, like, once you force over there, it'd be.
When I did the first
-29.
step,
Yeah, it'd be -29, so it'd be -6 minus -29.
oh, there it is.
23.
There it is. You're adding in a negative, another negative. So that's where this changed my life. I stopped looking at it as what I'm doing. Like that, to me, yes, it says to subtract. But if I'm gonna say subtract, then I've already used that negative, and I can't have another -29. That's good. That's where it was for me. That's exactly what would happen to me. And like, so it helps to be like, hey, wait, let's not look at that as a subtraction or whatever you want to do. Just know that you can't, you've got to use the signs that are there. Like, don't throw in extra signs. Because that's the story of my life. I'm all about making things confusing in my world. So just more practice with that. Do you need me to do this one or can we keep going? Anyone? So number 24, we're skipping over or just gonna let y'all do it. What about this one?
Yeah, we need to do that. For the same thing, for the flip, yeah, that kind of took me out a little bit.
It's good. Keeping your thinking.
Yeah.
Keeping my brain going. So first step we think about, when I first saw these questions, I didn't think, in fact, like the first few times I taught them, I didn't really think, I treated them just like a normal equation because it was not screaming at me that it had the same thing on both sides. So basically, anytime, I'm not gonna say that because then you get into messing up the rules. So I'm still gonna treat this like one we just did, where I'm gonna move the variable, and you can move whatever you want to first, but I'm gonna move my variable first. When I do that, I lose my variable in the whole equation.
Mhm.
Don't try to force the variable to be there. That created 0, and then that created 0. So we scoot in with what we have left. -15 equals -15. Is that a true statement? Then that means that all numbers will work. That this solution set is infinitely many, or whatever they want to call it. Solution is all real numbers. So all numbers would make this true. So if this is yes, then your answer will be all real. We'll make that true. We'll make that work. Because that makes sense if you think about it, the exact same thing on both sides, which is kind of silly. And I was like, oh, it took me a minute, but I was like, oh yeah. But be careful with that because something like that, we get, like, we love all the little shortcuts and all the little, like, unique cases. And then you want to hold on to them and use them for everything. So I almost said it and I backed up. Just because the variables look to be the same on both sides does not necessarily mean that they're going to cancel. You need to go through the steps of moving those variables and using your rules to make sure that it does cancel out. So when I do it this way, it's not going to cancel out because that is a -8 and a negative. So that needs to be -16. So it did not go away there. Because when I moved it, it canceled, it looks like it canceled out because they're opposite signs over the wall, but the movement over the wall changes the sign. And so we're no longer looking at opposite signs. So be careful with that little unique case. We get excited about unique cases and we want to use them for everything. So this next one is similar to this, but we're going to solve this one down and get the same picture where the question, is it true? So moving your terms around. Gonna subtract the 4y. They cancel out on both sides because they are opposite signs and then signs. Then we get down here to negative 14 equals 8. Is that true? No. So there is no solution that's going to make this work. So you would choose the no solution option there. There's where we're getting at all the ones that y'all want. Everybody's been waiting so patiently to get into these. So looking at these. Everybody good on this one? Okay. Best option here is to first draw your wall and then go through and label your parts. And this is where we get messy with our combining like terms rule. This is where we want to use opposite signs, so be really careful. So because you think about moving that 3 to that 6, anytime you're moving something, you want to change the sign, but it's really only if you're going over the wall. So instead, I would look at this as 6 minus 3 and get what? 3. And again, I'm scooting towards the wall so that I keep everything lined up. And so then I'm going to combine those, which again is 6 minus 3 again. Seems like it's been called something. Oh. Okay, no, I'm sorry. 6 minus 3 in front of the variable is going to give us a 3. So we have 3v. So we use those two here, and then we use these two up there. Just want to make sure we're clear on what we're doing here. That kind of crossing them out after you've used them kind of helps you see what you have left. So then you've got your rules for, and here's me moving it to the left because we're going to get into the inequalities. Would you have moved that to the left? What would you have done? Yeah. So moving it to the left is just it. You just have to be ready for a negative.
Yeah, that's what I turned off.
Yeah. So I avoid all negatives too. So I would have moved if I'm in the frame of mind of not worrying about graphing inequalities. Absolutely, I move towards where the variable is positive because I don't like negatives. So we combine like terms we go over the wall. We're now out of the cleanup step and we're going over the wall. We're in the add and subtract step twice before we can move onto another step. And again, I went to the left. I need to clean that up. And then now I have to go to the right. That is using a subtraction. That becomes 7. So this is where we would use our just flip the sign. So I solved it down and got down to this last little piece and it was positive. Now it's negative because of just that sign. And that's the kind of stuff people drop off too, is they forget that sign. So then you get into the parentheses, and this is where I put back on that PEMDAS that we do multiplication early in an equation and solving an equation only when there's a parentheses. That's the only time you're doing things out of order. But it's not like you're not doing it to go over the wall though. You're just doing it as a cleanup. And so that's what I call clear parentheses. And then my last one on this that we haven't talked about is to clear the fractions. But we'll get to that if we have time. So that's my cleanup stuff. So there's like 3 levels in the cleanup. That's all happening before you go over the wall. So I am notorious for carelessly not distributing that properly. I'll do the 2x, but then I forget to do that, the 2 times 4. Does everybody understand that that's distribution, that's multiplication? So we get 2x plus 8. And then it becomes another problem that we just make decisions on what needs to happen by checking out what's going on. And this is one that people would probably say that they want to go that way with it. So let's do that. Though if we did go this way, I like to do that too, because I like for us to be comfortable seeing 0. So we can do it both ways. Doing it this way, you don't have to remember to flip a sign. And I think that's what I get most uncomfortable with too, especially if there's a chance that's going to simplify down to a 1 in front of the variable. If it stays a number, it's not too bad. But we went to the left with a variable on that one, so I have to go to the right. And everybody gets tripped up by that, but what happens there? I subtract 8 from both sides. So it's 0 minus 8 is going to give you -8. If that ever is going to trip you up, just put it in your calculator. Don't assume you're going to, a lot of people want to make that 0 just because of the rule with dividing or multiplying with 0. You just get it all jumbled up. So notice that requires us to deal with more negatives, but it also keeps us on the same side. But we get the same answer. How are we doing? Multiple parentheses, same process. It's the same process of distributing on both sides. How are we doing with that? Those of you who did it last night. More of that. Let y'all keep playing with those. So distributing the 15, and then it becomes just another. So all of these last 6 are just cleanup stuff. It's right here. And so that's the newness of what you're doing. And then after you cleaned it up, you're back into the old, that becomes an equation you already know how to do, that we've at least done previously. But this one gets tricky because of that negative. So let's look at this one. So I have a lot of students that want to go ahead and do the math right here. That's where we get in trouble, because that's not PEMDAS. We got to do parentheses first. But not only that, I highly recommend that you use the sign with the 2, because otherwise you got to remember to deal with that negative as the stuff comes out, and we just tend to forget. So I cannot stress enough to take that negative with you. And so that becomes -2 times 3x. And then that becomes, yes, -2 times -1 becomes a +2. That's the kind of stuff we all make careless mistakes with. So that becomes -6x. That becomes +2. And I could easily have not done the negative and done it, and then but you have to then deal with the negative, and that negative has to be distributed with it. So it belongs to that 2. You need to use it and take it with you. So then it becomes one like we just got done doing. So we combine like terms there. I just made that. Look at that. I just subtracted those. That's not. So then we move. In this case, it makes sense to go ahead and just move the number over to the other number by subtracting it. How'd y'all do with that? Or those of you who may have struggled with this one, does that kind of help clear it up? Use that negative with the 2 and go over the wall with the negative. Take the negative with you.
Since you.
I think about,
If you got because if you were to add the 6 to the other side, wouldn't it be 6x plus 8 now? The 6 up to the other side. You understand the other side?
if I would have moved the variable.
Yeah, because you moved the 6 to get the 8, so wouldn't it be negative 6x plus 8 now? So you moved the 6 to the other side.
It doesn't matter. Yeah, he's asking about order here. Like it didn't, so it's either or, is that right? You're asking that, or?
Yeah.
And so then I move the 8 to the other side. Order doesn't matter when, as long as your signs are staying. That's why I'm like, if you can just wrap your head around that those signs, the term belongs, the sign all the way out to the variable belongs together. This is all together. And we'll get into the fact that that means out to its exponent. So the sign, the coefficient is the negative sign. It is the sign and that number together. It's called the coefficient variable exponent. Okay. Questions on that? Those last two. How about we take a couple minutes and go, and if you need to, walk, take a stretch for a second. If you don't, we'll move on. But do you feel like, I want y'all to feel free to take your breaks as you need them. But if there's a chance that you're worried about I don't think I need to share the screen anymore. So again, just reiterating that your terms begin with the sign that's in front of it and go to the back of its variable. So every sign starts a new term, and then that sign though belongs to that term. So then -1 times -12.
Again, -3y plus 12.
Could we try that again? You got me, Skylar?
Yeah, 2y plus 12.
Yeah.
Yeah, equals 28. I wasn't sure if you saw me or room.
Just I heard you say 3. 'Cause your brain did.
Yeah.
But, so
I'm still-
multiply. Then, so once we get these cleaned up, this clearing of the parentheses usually gets you back on track, and you like, that doesn't look like a scary question anymore. It's that parentheses and the negative that sits outside of a parentheses that I put multiple in here because it is going to be something that needs to just be natural and automatic. We're going to be using the idea of this negative being in front of the parentheses a lot, where we need to pull it out and put it in front of the parentheses, or when we need to push it through. And so this is where we pushed it through. We get 4y plus 12. Anybody having trouble with one exactly on your paper that after seeing this, you still don't understand it? What is that? What is that? Thank you.
4.
Yes. That makes sense for those of us who are still struggling with that. So then there's our last one. Just like my kid, y'all see parentheses, negatives, and you're just like, nope, can't. And that is a natural, that's like me in basketball. Like, please don't give me a ball. I just don't want to. But I'm not, basketball is not part of my education, thankfully, so I can avoid them. You don't get to avoid this, you gotta get in and get your hands dirty, okay? Get comfortable with being uncomfortable. This is gonna be the whole class. And then know when you get done with this class, even if you decide that you cannot finish this class this semester, you will have grown just from the work that you put your body through. I promise. This is lots of exercise for your brain, even when it doesn't feel like it, if you're not being successful. Promise you'll be successful the next time if you have to retake it. But I don't have that in my sights for any of you. We'll all be successful. So green is not my favorite in here. It's really light. Help me remember that next time. So again, looking at it, we read everything left to right. I recommend math. Math does the same thing. And so let's look at it this way, going from here to there. So this 7 doesn't have a sign attached to it, so it is positive. So that is just going to be 35x plus 63. This is when we move over and we've got to make sure we're paying attention to that is a -1 that distributes. And so we get that 18 minus x to the rent, again, -1 times x and -1 times +9. Yeah. And so then we're back at, we're still in, we just cleared the parentheses. Now we go back up to combine like terms. These are all within however you want to look at them. It's just, this is how we learned them today, but it's usually going to be clear the parentheses, then combine like terms. And then we look at cleaning up the sides. So this one is fine. But as you look and label, -18 minus 9.
Yeah.
You want to do that number first. I don't want to do the number first. I'm going to do my variable.
Yeah.
I just like to get my variable then handled, mainly because that's where I mess up too. And so I'd rather get the stuff that I mess up with. I just save the easy for last as much as possible. Yeah, I don't know. So then we get 36, right? X, that's a 1. That gets kind of confusing too, because it's like, so make sure if you need to write yourself a 1 right there. So you realize that is 36, 35 plus 6 plus 1. And then the 9.
What happened to the 18?
I combined it right here. Good question. And combined it means not switching any numbers around. That's always a challenge for us. So because I moved the variable to the left, I have to move the number to, oh gosh, see, so I can skip a lot of steps. So I get real eager. It took me a lot of years, a lot of semesters of teaching to stop skipping steps. And so that's what I would be able to see that you like if you move your 63 without showing me this particular step, I will be able to understand that.
That's an 18.
18 minus 9, give us 9. That stalled me for a minute to see if I can get, oh, this is a fraction. This is why y'all hate this one.
Yeah.
So what does this become?
54.
-54. And then you think you did something wrong because 36 doesn't go into -54, right? Like most of us have a little bit of number awareness, feel like, well, that's not going to divide. So that's when we just need to straight up put that in our calculator. Put that exactly how you see it. 36, what, 54?
No, 54.
Over 36. And so, sorry. So I pressed enter and I would normally have plugged it in and not pressed enter and gone straight to my, so from here, I would type it in and then go ask it to go ahead and convert it because I don't care what the decimal is. So that's not a big deal. You just know that you're gonna have to convert it back to a decimal. So again, I don't care what the decimal is. I'm just putting that in and asking for it to convert it to a fraction, which that makes sense, right? It wasn't what I was thinking, But 18 comes out of that. If I were reducing this one by hand, I would have started with 9, because I do see the 9. And I would have gotten 6 over 4. And then I would have hopefully seen that would reduce further. So this is just by hand. 2, 3 halves. So this is, again, by hand. But that's why I want you to get comfortable using the calculator, because there's no reason, because a lot of people might get stuck right here, might have been like, oh, that's it. Because you honestly sometimes just think it just simplifies once. But you've got to simplify it until it's as small as it can get. That's all I got, folks. Got time to get on the computers, or you can take a break and we'll see you on Tuesday or tomorrow if you need help or want to come up here, or if you're for another class and want to pop in. Otherwise, if you're wanting to work, you can. I know y'all don't have class until 12:15, so you're welcome to hang out or go get yourself some lunch. Take a little bit longer break.
So the 18 got put the grill.
Yeah.
Now, I'm gonna go through the videos. I feel like this, I think it's because we go off into that little thing down here. Distract me completely from what we're doing.
I would love for it to stick to just that.
Yeah, you know what I mean?
There's always somebody like, what you just do? So I had learned to write in all the steps, but then it's just. Because you're right, I'm one of those that we go down a rabbit hole, I live in a rabbit hole.
Yeah.
Like, it's hard to come back. Like, wait, we're not staying here? We have to
What was
get
we
up
doing?
here. Yeah.
But nah, I don't know.
I'm going to do.
No,
What?
I got that.
I don't think I can do one paper.
Um,
I can do one. I gotta get,
yeah, that's why I'm having to do it like this, because I keep wanting to do like when I write corrections, I keep wanting to do, yeah.
No, I don't. Unless you don't
And it
have that
just does not work.
function.
I have lines.
I got an extra, well, I'm gonna go buy some, let's make a paper. You want me to write in?
Yeah, go ahead. I'm like a notebook.
Yes.
I'm gonna have to go home, I guess, and do my
Yeah.
class. and English class at home.
Oh, you sure? Yeah.
Mhm.
Go back home.
Which is good for me.
Maybe not.
So what are you gonna get together to do this next one? Raven? Huh? Yeah, Friday, sure. But I gotta get on my. I gotta get away. I gotta get away. Okay, that works. Just leave me on my.
So hard. About how to read these student, I don't know, but I'm gonna. Same thing for, any time, I usually turn off. So if I haven't done that, you see that the way the timer shifts on, I just, you know, but I do use it. My kids do the extra time. It's just easier that way.
Great, everybody's kind of.
Yeah, it's a long lecture.
Yes, ma'am.
This is like an example. This is my question, the 27. Yes. That's where I got.